Okay, in this video we're going to take a look at some problems from section 2.3. These are similar problems found in my math lab for that section. So this first one tells us to use the fact that trigonometric functions are periodic to find the exact value of the given expression. And again, it says do not use a calculator. So remembering that the period of cosine is 2 pi, which is 360 degrees, we could take 420 and subtract a period, which is 360. And we see what you're left with is 60 degrees. So the cosine of 420 is going to be equal to the cosine of 60. And the cosine of 60, as we've shown several times in class, is going to be 1/2. All right, on this next equation, it gives us the value of cosine theta and tells us what quadrant we're in. So we're going to use the fact that this is in quadrant 2, which means that the x value is negative and the y value is positive. And recall that the x value is the cosine and the y value is the sine. Okay, so we can see that we already see that the cosine is negative, but we'll need to know that the sine is positive to complete this question. So we can draw ourselves a little triangle, right triangle, and cosine, remember SOHCAHTOA, is adjacent over hypotenuse, so we know that the adjacent is -4, okay, which matches up being in the second quadrant, and the hypotenuse is 5. So we can use the Pythagorean theorem to find the other leg of the triangle. So recall that the hypotenuse squared is going to equal the legs of the triangle squared. So -4 squared plus b squared. Okay. So 5 squared is 25. -4 squared is 16. And we still have this b squared. So we want to go ahead and subtract 16 from both sides, which will give us b squared equals to 9. And if we take the square root of both sides, we get b is equal to 3. Okay. Now we have all the pieces we need. Sometimes I'll just come over here and write opposite is equal to 3. And again, we know this is positive 3 because we are in the second quadrant. That adjacent is equal to -4. Again, negative because we're in the second quadrant and the x value is negative. And the hypotenuse, which is equal to 5. Okay? And then for the rest of these, we can just use SOHCAHTOA. So SOHCAHTOA, which is opposite over hypotenuse, would be 3/5. And then cosecant, which is 1 over sine. So remember, when we do 1 over a fraction, we flip the numerator and denominator, so this would just become 5/3. Okay. The cosine we was given was -4/5. So 1 over the cosine, which will be our secant, will be -5/4. Okay. Our tangent, which is opposite over adjacent, TOA, will be 3 over -4, and 1 over tangent, which is cotangent, we'll just flip it, the denominator, or the fraction, and be -4/3. Okay, so that's how you complete that problem. All right, in problem number 3, it says use the even and odd properties of the trigonometric functions to find the exact values of the given expression, and it reminds us do not use a calculator. So remember that cosine was even, which means that f of x, or f of -x equals f of x. Sine, we describe to be odd, and tangent is odd. And with odd functions, f of -x equals negative f of x. So let's see what that looks like here. So cosine of -60 is going to be the same thing as the cosine of 60, which again we've already shown is 1/2. Sine of -30 is going to equal negative sine of 30, which is also well, -1/2, right? Because sine of 30 is 1/2, and this is negative sine of 30. Keep in mind, too, by the complementary angle theorem, that 60 and 30 are complementary angles, and cosine and sine are cofunctions, so that the cosine of 60 is equal to the sine of 30. We can see that here. Of course, you have the negative out front, since this is negative 30, so we go ahead and make the appropriate adjustment. Tangent negative 45, tangent is also odd, so this is going to be equal to negative tangent of 45. And as we've shown, the tangent of 45 is when x and y are the same, and that's root 2 over 2. So this would be negative root 2 over 2. Okay. All right, now in problem number 4, it tells us that the cosine theta is 0.2. Let's keep in mind that the period of cosine is 2 pi. So here we're just adding the period, so cosine of theta plus 2 pi is going to be the same thing as the cosine of theta. And this is 4 pi, which is just a multiple of the period. So this is also going to be equal to the cosine of theta. So what we really have here is cosine of theta, which is 0.2, cosine of theta plus 2 pi, which is also 0.2, and the cosine of theta plus 4 pi, which is again 0.2. And if I add all those up, I will get 0.6. All right, using properties of the trigonometric functions to find the exact value of the expression, do not use a calculator. So let's recall that cosecant is 1 over sine. So when you're doing these identities, a lot of times it's helpful to try to start breaking things down to sine and cosine. And let's see how that works out here. So we get the sine of 61 times 1 over the sine of 61, and these of course will cancel out, leaving us with just 1. Okay, hope you found these videos helpful. If you'd like to see some additional problems, please send me an email.